The last learning objective that we're yet to cover for kinematics is plot and interpret a distance time graph and a speed time graph. Actually, I looked through the TYS for really many years, and distance time graph is actually seldom tested. Most of the time it's the speed time graph, and I guess it's because it's a bit more challenging, and there are more things to test about the graph after it's plotted. So I don't have an example for distance time graph here, but you can go and look for one if you want. But we're just going to go through the speed time graph example. Okay, so we need to actually know how to plot either of these graphs and interpret them. Okay, interpreting them we've already covered in the previous learning objectives, so that I'm going to go through that really quick. But let's just look at plotting now. A car travels at 50 meters per second for 2 minutes. Okay, so the I guess a tip for this, right, is when you're plotting and they give you information like this, break up the information to different parts so that you can handle them one at a time. Okay, so a car travels at 50 meters per second for 2 minutes. That's one set of information. It then accelerates uniformly to a speed of 30 meters per second in 0.5 minutes. Then it travels at a uniform speed of 30 meters per second for further 9 minutes before decelerating non-uniformly to rest at 1.5 minutes. Okay, so let's go one by one. The first one, a car travels at 15 meters per second for 2 minutes. So we've got speed here, time here. Make sure you always check the axis and be very clear of it. 15 meters per second for 2 minutes, right? So for 2 whole minutes, the speed is 15 meters per second. So if you were to just like, okay, I don't have a ruler here and my pen is really thick, so this is not going to look very good, but 15 meters per second for 2 minutes. You got that? 15 meters per second for 2 minutes, right? So the whole 2 minutes, it stays at 15 meters per second. What happens next? It accelerates uniformly. All right, accelerates uniformly. What does this mean? In a speed time graph, so this means constant acceleration, which means constant gradient for a speed time graph, right? Okay, so look at constant gradient, which is constant steepness. So you have a constant steepness to a speed of 30 meters per second in 0.5 minutes, right? So it's going to go up, constant steepness, so it's a straight line to 30 meters per second in 0.5 minutes. So 0.5 minutes is here, you're looking at reaching here in a straight line. Okay, I'm not going to be able to do that very well, but oh dear. Okay, imagine it's a straight line. Okay, you need to use a ruler. Anyway, you have the answers now. Okay, so it then travels at a uniform speed of 30 meters per second. So uniform speed again means the speed is constant at 30 meters per second for further 9 minutes. So 9 minutes later will be 7.5 minutes. Oops, sorry, wrong. 9 minutes later will be 11.5 minutes. So we're going to stay at 30 meters per second until 11.5. So I'm going to put a dot. Oh, it's so hard to see. I'm so sorry. It's here 11. This is 12. Oh, this is really bad. I'm gonna go with here. So a straight line across, 30 meters per second, uniform speed. Okay, and then before decelerating non-uniformly to rest. Non-uniformly means the gradient is not constant, which means the the steepness is not constant. The rest in 1.5 minutes. So in 1.5 minutes, I need to reach 0. 1.5 minutes, 11.5, 0.5 is 12, so I reach 0 in 13 minutes. Non-uniform. Honestly, that means you need to curve. You can curve either way, but the way that is correct, which will make sense, is to curve this way. Okay, that should be from the middle, yeah. So it will curve this way to rest. Why does this way make sense? Just a bit of a stretch, I challenge you. The speed decreases very fast at first, but then it gets less and less steep, right? Which means the speed decreases less and less quickly, so that it will slowly, gently come to a rest, right? So this is like a slow, gentle break. If you did something like this, let's say like this to a stop like this, that means that you very suddenly stopped. It's more likely like a crash will look like this, right? Yeah, just to test your interpretation. Okay, so that's plotting a graph. Fairly straightforward, right? Calculate the acceleration. Okay, so the key thing here is I don't know, just know where your starting and end point is, know whether you're going straight or you're going to curve, and then do it. Okay, and make sure you use a rulers for your straight lines, unlike what I did here. Alright, calculate the acceleration of the car as it increases its speed from 15 meters per second to 30 meters per second. So they're asking you from here, 15 meters per second to 30 meters per second. They know it's a straight line. So how do you find acceleration? A equals to v minus u over t, or simply the gradient of the speed time graph. Either way is fine. So this will be 30 minus 15 over 0.5 minutes. Okay, but you see here is per second square, so you cannot use 0.5 minutes. 0.5 minutes, you need to convert that to seconds. So 0.5 minutes is 30 seconds. Okay, so that's 15 over 30, which will give you 0.50 meters per second square. Remember to never leave your answer in 1 SF. Okay, so 2 SF, 2 or 3 SF is fine. Next, calculate the distance moved by the car when it was traveling at 30 meters per second. So this is again recap. Now we're looking at distance traveled when it was traveling at 30 meters per second. Distance traveled is the area under speed time graph. Okay, how do you find the area under speed time graph? It will just be length time breadth. So this will be this of course is the height is 30, right? The distance traveled, the height is 30, and then the breadth is they told you how many minutes it is exactly, 9 minutes, right? So distance traveled, please make a habit of writing these statements, equals to area under speed time graph. This will be 30 meters per second times, okay, so it says of course it's 9 minutes, but you need to convert 9 minutes to seconds because it's meters per second, so you need to convert it to seconds. So it's 9 minutes, 9 times 60 seconds. Alright, so for 1 minute 60 seconds, so 9 minutes is 9 times 60 seconds. Okay, this should give you 16200 meters. Okay, so that's all for this question.